Hello, I'm Leif Johannsen from Ortofon. This is the third video in a series about what makes a cartridge good. Previously we made a video about cartridge principles, moving magnet versus moving coil, where we discussed the principles, how they work. We had the next video, it's about technologies, Ortofon technologies that we employ to enhance the performance of our cartridges, and that was both for moving magnets and for moving coils. Now this third video is about materials. What materials we use for the different parts in a cartridge. A cartridge really contains a lot of different parts. To make it a little bit easier to go through all those parts, I've divided into five groups, sort of to make it easy to come through them. And this is, as an example, MC Verismo. I have some Verismo parts over here. So we'll start out on the outside. The housing, of course, the big part, the interface between the magnetic system and the tonearm and headshell, which is very important for the performance of the cartridge. We have it lying around here, big part. Next part, when we dive deeper into it, is the magnetic system. I have it lying around here. So we have both magnets and pole piece, and we can see the whole magnetic system here. So that is the next one. Then we dig even deeper into it, and we can see that here, where we now can see that we have a rubber suspension system, which is the interface between the stationary part in the magnetic system and the moving part. So very important for the performance of the cartridge. Next will be the armature and the coil wound on the armature in this MC cartridge. And the last one in this materials video will be the cantilever material. Of course, at the very end of the cantilever, we have a very small part, but extremely interesting and extremely important. So that part I will not discuss in this materials video. That part, the stylus, needs a separate video to cover all the interesting features about that. And now in this third video, we are going to talk about the materials that we use for the different parts in the cartridge and why we have chosen them and why they might be very special. So first I will talk about housing, cartridge housing. A few things to say about that is that the housing is, of course, important interface between the magnetic system and the headshell, tonearm, so that few properties that is sort of essential for this housing, and that is rigidity. We want to be able to ensure that the magnetic system is really kept into place when the cartridge is mounted on the headshell. There are also other things that the cartridge need to be easy to mount on a headshell, and if you can achieve it, then some kind of surface which is resistant to scratching or stuff like this, because this housing is the part that the user will touch when mounting the cartridge and using the cartridge. So there are different things that you have to take into account when you design the housing and also when you are choosing the material for the housing. I'll take these two parts away. I don't need them now. And then we can start to look at these two parts. This is the Verismo with SLM, selective laser melting housing, which I have here. Selective laser melting is one of the technologies that Ortofon is employing to achieve really the highest possible sound quality in our exclusive series cartridges. We've been using this for many years now. It's about using a laser or a couple of lasers to melt together powder, very fine powder of metal until we get the structure that we want. So we get the housing, the outside structure, but also at the same time we can have damping inside, so that we have the possibility to create internal structure in the housing. This is titanium. The first parts we made was made out of stainless steel, but titanium is really superior material when we talk about SLM process, because it is very stiff. You can achieve really high rigidity in the housing, and it's also more lightweight than stainless steel. So titanium is almost the perfect material for this kind of selective laser melting housing for our exclusive series cartridges. So we are at the same time really having rigidity and damping. It's also user-friendly, and it's a nice place to mount the magnetic system. So all in all, this is a very, very good housing for this kind of cartridge. And remember that this is not easy to make. This really requires pretty advanced technology to make it and afterwards to get the tolerances that we need. So a very advanced type of housing. And as far as I know, Ortofon is the only cartridge manufacturer that are making this kind of housing for their cartridges. This is Ortofon technology. So titanium for this kind of housing. When we move to a different category of cartridges, let's go to the MC cartridges. I will use the quintet as an example. So this is just one out of the whole quintet series I use as an example here. I'll take two parts forward, this one and this one. I'll take off the stylus guard, then we can see more clearly how it looks. Inside here, we have, you can see it also down here, we have this part, which is an aluminum frame. So this is a frame that at the same time makes it possible to mount the cartridge on the headshell or tonearm. And if you look inside, you can mount the magnetic system inside. This is a machine part made out of aluminum. Aluminum is extremely suitable for this because it's lightweight. We do not want cartridge to be too heavy. So this is lightweight material. Aluminum is also nice and stiff. It's easy to machine. We can achieve really nice tolerances when we are machining this kind of part. So all in all, aluminum is a good material to choose. We also use aluminum if you look at our cadenza series. So aluminum is well known as a good cartridge material. On the outside, to protect everything inside here, because now we have the magnetic system mounted here, all the delicate parts are in here. So we need some kind of protective cover, and that is made out of plastic or polymer, whatever name you would call it. This is injection molded part. Injection molding is extremely efficient production technology. So as soon as you have made your mold, you can make a lot of parts. So we make parts in different colors for the whole quintet series. And even if you say, oh, this is a plastic part, well, I would say this is, a plastic part or a polymer part. But today, there are a lot of really good choices for this kind of compound that we use for housing. You can get scratch resistance, you can get damping properties. There are many possibilities to choose the right polymer for the purpose. And also, if you look at cost efficiency, then injection molding is a lot more cost efficient than making SLM housing. So injection molding is not bad, it's really effective in this way. Moving to the next type of cartridge, which was 2M Red, as an example of the whole 2M series, really a popular series in our lineup. And this is also made out of plastic or polymer. So the body and the stylus part. And again, scratch resistance, damping properties, all this kind of choices you have when you're looking at what kind of polymer you want to use. And also, when you are making injection molding, there's also it's really possible to achieve extremely tight and repeatable tolerances. So inside here, where you have to mount the cantilever and rubber suspension, we can achieve really tight tolerances, really high precision to make this cartridge work as it's supposed to be. So all in all, again, cost efficiency is of course very important here because of the large quantities, but injection molding for this kind of cartridge, choosing the right kind of compound, is extremely efficient and good, both for sort of handling, but also for the sound quality. So a few examples of what we use. So really advanced SLM technology, machined aluminum part, injection molded polymer part, and again here injection molded polymer parts. That's sort of the range of what we are using. The next topic I'm going to talk about in this video about materials is the magnetic system. So on the table I have now lined up these things where I looked at the housing. I'll take the housings away. I don't need those now. Like this. And in fact, I will add a cartridge here because this cartridge I'm adding now, the MC Diamond, contains a very special magnetic system that I also want to tell you about. So we have 3 MCs now, 1 moving magnet. The magnetic system is a very central part in the cartridge. This is where the movement of the stylus through the cantilever will be transformed into an electrical signal so that we can listen to the music in the groove. The MC system, of course, at the end of the cantilever will have the armature sitting. That armature with the coils is sitting in an air gap where we want to have a magnetic field so that we can generate this electrical voltage so that we can listen to music. The most important thing for those MC magnetic system is to have a very strong and uniform magnetic field in the air gap. This is what counts here. Over here, where we have the moving magnet, it's a little bit different because here we have a very tiny magnet moving between some pole pins, these split pole pins that I've covered early on. So here it's not so much about having a really strong magnetic field. Here it's more about being able to conduct the magnetic fields that we have in a very, very efficient way. So it's a different approach, but at the end, of course, it's about getting this transformation of the movement to the electrical signal. I want to line up now the magnetic systems so that we can look at them, and they are very different. And this is because these cartridges are also very different. So we are not using just the same magnetic system for all of them. For each of these series, we have a dedicated magnetic system that makes sense to use. It has the performance that we want to have. We're also talking about price points because some of the parts we are using in those magnetic systems are really expensive, and for some other parts they are less expensive. So this is also important to have that in mind when we are designing cartridges and choosing the magnetic system for the cartridge. So let's start out with the left one, MC Diamond. That magnetic system I have here, and that is very strong magnetic system. I'll come back to why, but it's very strong. This means that I need to keep a certain distance to the other ones, else it would attract and they would sort of clash on the table. So I'll take it apart and you would see I have some common parts in this one and in the next ones I'll take apart. So I have a front yoke, I'll have a magnet, and I have a rear yoke with a pole cylinder in here. So like this. The next one, the Verismo, that is a very compact magnetic system. So very compact. This one, again, I will have a front yoke. I will have to twist it a little bit to get it off. I will have a magnet, rear yoke. And next one, the quintet, same story, front yoke, magnet, rear yoke and pole cylinder, and then for the moving magnet over here, I have the pole pins with the coils, and I need a pair of tweezers to get the magnet and put here, like this. Very tiny magnet. So these parts are sort of common: front yoke, magnet, rear yoke. And the thing about all of these parts, in fact all parts that you would normally use in a magnetic system, is that iron is the most important ingredients. So they are metal alloys, but with iron as the most important ingredients. And then for the different purposes, whether it's going to be a permanent magnet, what you would just call a magnet in daily life, or if we are talking about a yoke, which is made of what's called soft magnetic material, iron is the main ingredients. If we start to look at these three magnets in the moving coil systems, they are all made out of neodymium, iron, boron. So in daily language, just neodymium magnets. We are choosing neodymium magnets because of the really high energy density in those magnets. So high energy density in the magnet means that we can achieve a really strong magnetic field in the air gap, which is what we're aiming at. If we look at the rear yoke over here, and rear yoke here, and front yoke, and rear yoke, and pole cylinder here, they are all made out of an alloy which is mainly almost 100% iron. And one of the important things about this alloy is this low carbon content. So this is a very good material to use in magnetic systems. For this front yoke, and for this pole cylinder in here, we're using a special, really special alloy with a lot of cobalt. So it's an iron cobalt alloy that allows for a very, very strong magnetic field inside the metal, and therefore also a strong magnetic field in the air gap. So this is a very special alloy that we have chosen for these ones to have the best possible performance for each of these categories. Now moving to the moving magnet. As I already mentioned, it's very different. So it's a very small magnet here, not neodymium. It's a very special alloy that we use, very different. And then we have the pole pins, where I mentioned that it's important that the magnetic field can flow extremely easily. And those are made out of something we call mu metal, which is a iron nickel alloy. So the nickel has been added to really enhance the flow of the magnetic field lines inside those parts. So iron in general, but with a lot of different other sort of metals in the alloys. If we have a special look at the MC diamond system, then I mentioned that we are achieving a really strong magnetic field in the air gap. And this is necessary because for the MC diamond, we want to use a non-magnetic armature. I'll come back to that in a short while when I'm talking about armatures, but non-magnetic armature over here makes it very, very important to have this strong magnetic field. So this gives you sort of an idea about what kind of material we are using in the magnetic systems, and also how they look when we sort of take them apart here. The next topic I'm going to talk about is the interface between the stationary part of the magnetic system and the moving part in the cartridge. That interface is our rubber suspension or our rubber suspension system. The properties of this system is very critical for the performance of the cartridge, extremely important for the performance of the cartridge. So let's have a look at what kind of interface we have here. I can put forward 3 different cartridges. You've seen them before, a 2M, MC Verismo, and MC Diamond. And then I will show you how the rubber suspension inside each of these cartridges look. And they are small, as I can show you. This is a rubber suspension for a 2M cartridge. In the Verismo, in fact, I'll come and show you 2 rubber suspensions, because in the Verismo we have a wide range damping system, which requires 2 rubber suspensions. And in fact also in the MC Diamond we have 2 rubber suspensions, because also in the MC Diamond we have the wide range damping system. So they look like that. Not very big, but as I mentioned already, extremely critical for the performance of the cartridge. These rubber suspensions are produced at Ortofon factory. In fact, they are developed, tested, and produced at Ortofon factory. Ortofon factory has its own rubber mixing facilities where we have specialists in mixing those rubber compounds. We have specialists testing, developing those rubber suspensions. Our engineering department has dedicated engineers focusing on rubber suspensions. And of course, in the production, we have dedicated operators making sure that what we produce is up to the highest quality level. Each and every of these rubber suspensions that we use in our cartridges are controlled under microscope. In fact, Ortofon is the only cartridge manufacturer that has its own rubber department able to develop, test, and produce rubber suspensions. And that is very, very important for us to have this 100% control, because this means that this critical part in the cartridge is our own. We determine 100% how it's going to be, what the performance is going to be, and therefore we are able to make really high performance cartridges, because also we have this in-house knowledge. How do we do it then? I have a few parts I borrowed from a rubber department. A raw piece of rubber. Of course, this cannot be used as a rubber suspension, but this is a raw piece of rubber, which is the main ingredients in the rubber suspensions. We mix this base part with a lot of different ingredients, determining the properties, the final properties of the rubber. And those final properties will typically be compliance, or how soft they are, or how hard the rubber are, whatever phrasing you would like to use, but also how much damping we have in the rubber suspension, which is a very, very important property for rubber suspensions in cartridges. In fact, we also sell rubber parts for the hearing aid industry, because they also need rubber parts with really well-determined compliance and also well-determined damping properties. To demonstrate the properties, I have two balls here. Yellow, blue, the color does not really matter. It just makes it easy for you to distinguish the two balls. They have same compliance, same stiffness, softness, what you want to call it, but they have different damping properties. So I'll take the blue ball, drop it. This is what I call a rubber ball. This is also what I call a rubber ball, but with a lot of damping inside. So what happens is, in fact, that the energy from the fall is dissipated inside the rubber. So it disappears inside the rubber. Here, not. So if you look at them at the same time, this is what they do. Got them. Okay, so this is really demonstrating what damping means. So we mix this, and then we end up at something like this kind of sheet. So this is raw mixed rubber. This is where we end up after adding ingredients and then mixing it in our mixing room. There are a couple of different things going into this, but one thing I'll just mention is that lately we've been using a new ingredient which is called carbon nanotubes as an ingredient. And that carbon nanotubes has now expanded our possibility to have really high-performing rubber suspensions. So rubber suspensions where we use rubber with carbon nanotubes, we are, for instance, using in the MC Diamond like we have here. We are also using it in the Concorde Elite. So we are really using this kind of new ingredients to enhance performance of our cartridges. And going from this step to this step, we are now very close to being able to make those rubber suspensions. So this part is then cut into smaller pieces and put into molds. And this mold then will be pressed together under high pressure, high heat. And after a while, it will be opened, and out the operators can take out the rubber suspensions. And as I mentioned, they are controlled, each and every of these under microscope. And then they are in fact, after that, going into an oven again for some days before they are ready to be used in the cartridges. But for Ortofon, it is really critical and very important that we have all this knowledge and the production in-house. This ensures that we can produce high-quality cartridges. So I just talked about rubber suspension systems. I talked about this interface between the stationary part of the magnetic system and then the moving part. So the next thing I'm going to talk about is now the moving part. When we're talking about MC cartridges, then the moving part will be the armature with the coil. That is the one which is sitting next to the rubber suspension. If we're talking about moving magnet, it's of course different because now it's the magnet that is moving. So there we will have the cantilever with the small magnet to be the next component if you look at the rubber suspensions and go to the moving part. I will start to focus on moving coil cartridges, and after that I will then also talk about the moving magnet cartridges. I will use these cartridges again as example, where we have the MC Diamond, we have the MC Verismo, and we have the Quintet, 3 MC cartridges. And then we have the 2M Red as a representative of 2M cartridges. How does the armature look for these cartridges? So I have them over here. And the armatures I'm going to show you is not just the armature, that is the armature with windings plus a rivet, a small component that we need to connect the cantilever to the armature. So this is also part of those armatures I'm going to show. So let's start with the armature for the MC Diamond, like this. We have the armature, the MC Verismo here. And we have armature for the Quintet here. And then for the 2M, I don't have an armature. I have the cantilever with the magnet, because this is what is moving. So first of all, let's talk about the material that we use for the armature, and after that I will then talk about the material in the coil wire that we use. MC Diamond, as I mentioned when we talked about magnetic systems, is having a really strong magnetic field. It's been developed, the magnetic system, to be able to produce a really high magnetic field in the air gap, because we want to use a non-magnetic armature. So this armature is non-magnetic. I'll come back to that. I'll now jump to the Quintet. The Quintet is using a more standard armature that we use in a lot of our MCs, and that armature is magnetic. That is mainly made out of iron. So that is magnetic. And in between we have the Verismo, and the armature in the Verismo is in fact made out of an in-between material. So the material for this armature is what we call a semi-non-magnetic armature. So semi-non-magnetic armature. And what does this mean for the performance of the armature if it's magnetic, semi-non-magnetic, or if it's non-magnetic? So what is the meaning of that? If we start out with the Quintet and you have a magnetic armature, then that magnetic armature is placed in the air gap where you have a magnetic field. So of course the armature will sort of feel the static magnetic field in the air gap. So you will affect the armature through the stationary magnetic field. And as we also learned when we talked about technologies, when this armature is moving in the magnetic field, it will disturb the magnetic field. So this is where we, for some of our cartridges, are using this field stabilizing element, sort of to correct for this disturbance. So there are a few drawbacks by using a magnetic armature, but there's also a very big advantage, and that is that the output voltage is enhanced, is amplified by the fact that we use iron for the armature material. So there are some benefits and some drawbacks by using iron. But we use this kind of armature in most of our MC cartridges. Now jumping to the MC Diamond, non-magnetic. And why do I want to use non-magnetic? Of course, it makes sense, because non-magnetic means that it will not be affected by the magnetic field, the static magnetic field in the air gap. It will be totally independent of that, and also the movement of this non-magnetic armature will not disturb the magnetic field. So when we are having a non-magnetic armature, you do not need field stabilizing element. So this is the optimum to use, but you are not getting this amplification of the output voltage. So if we did not have this very strong magnetic field in the MC Diamond, the output voltage would be really, really, really low. So therefore, it's important to develop this strong magnetic field to have a sort of suitable output of the cartridge. So that goes together, strong magnetic field, non-magnetic armature. And then in between, as I mentioned, this semi-non-magnetic armature made out again of an iron alloy, but not as magnetic as over here, but not totally non-magnetic. So this is sort of having a little bit of both worlds. So this is a compromise. It's not totally non-magnetic, but it's more than over here. So so freedom for the motion is definitely bigger for this one than over here. But the amplification of the output voltage is not as good as for this one. So therefore we will have a lower output voltage. So it's a compromise between the magnetic and non-magnetic armature. So these are the three types of armatures that we are using. The armature material has significant impact on the sound. This is important to really now make sure. So if you're using this non-magnetic armature, you will achieve an openness and a freedom in the sound that is just amazing. You can almost feel how free this armature is able to move because it's non-magnetic. It's a really explosion of details when you are using non-magnetic armature. But on the other hand, we know how good a sound we can get out of the semi-non-magnetic armature, which is sounding superb. And also for all our MC cartridges, they're also sounding really, really good. But this is really our top of the line cartridge, so this is also important that we use the best kind of armature that we have. Coil wire. Yes. We use different kind of coil wires for these armatures. So if I now take forward this one, that is a gold-plated copper wire. We call it aucurum. So that gold-plated copper wire is used in the Verismo. I have here a pure copper wire. This is in fact used in the quintet, but we also use copper wire in the MC Diamond. Not the same copper wire, it's a different one. I do not have it here, but also over here we have a copper wire. And then, just to sort of show you that we're also using third kind of wire I have here is silver wire. So we also use silver wire for some of our cartridges. So these different wire types, that is, we are choosing those at the end of the design process. Designing the cartridge means, of course, we are looking into a magnetic system, rubber suspension, armature, cantilever, stylus, and a lot of things. But we also need some wire on the armature. But what kind of wire we are going to use, we will determine as one of the last steps in the development process. Because this is a sort of a flavoring of the sound. This is a harmonizing of the sound. We have chosen the components in the cartridge so that they together will produce the sound that we want, our Ortofon sound. And at the end, we can use the wire to make a final harmonizing of the overall sound of the cartridge. But it's important to have in mind that these wires are not just going and changing the sound totally for the cartridge. This is a flavoring, a harmonizing of the sound, but still very important as a last step. But this is last step in the process, in the development process, in the listening process of the MC cartridges. Now, of course, we also have MM cartridges, a lot of MM cartridges. Stepping a little bit back here, you might be able to see it, but on these armatures, we do not have that many windings. These are hand wound and high precision hand wound. And that is the only way that we can really get that precision and getting this wire onto those small armatures. When we are talking about moving magnet, and we're talking about the coils that we're using there, then they are machine wound. I have here the coils on this split pole pins that we have seen before. And these coils, each of them have a couple of thousand windings, where over here you more likely have 30 windings per leg of this cross-shaped armature. So a lot more windings over here. So this is done by a machine. We need a machine for this. And also the wire that we use over here is significantly thinner than the wire that we use over here. So machine wound to be able to really put this big amount of wires in the coil, and over here hand wound to achieve the precision that we need. So our skilled operator are really able to do this manually by hand under microscope, placing the wires exactly where we want them to get the performance that we are aiming at. And over here, of course, it's a moving magnet, so it's not the armature, which is the interface to the rubber suspension. It is the cantilever with the magnet that we can see lying around here. So very different system, but still sort of containing the same ingredients as we have seen many times before. The next thing I'm going to talk about is cantilevers. So what is cantilevers? I want to show you. I have a 2M red here. Take off the stylus part and the protection. And then we can look inside. And this small part, this metal part sticking out here, very tiny part, that's the cantilever. I can show you a little bit clearer. So now this cartridge is not really functioning anymore, but now I have the cantilever here in my hand. That cantilever is made out of aluminum. I'll come back to that, why aluminum is a good material for cantilevers. So what is the purpose of a cantilever? At the very end of it, you could not see that, but at the very end of the cantilever, you have the stylus, and at the other end, you are having some kind of attachment to the housing. And that attachment for the moving magnet is to the magnet, and if we're talking about moving coil, it's attached to the armature. So the cantilever is connecting the stylus to the generating system inside the magnetic system. So what we want to have is a transfer of the movement of the stylus in the groove through this cantilever to the coil or to the moving magnet. So that is the really important thing for the cantilever. We must be sure that we have the best possible transmission of this movement from stylus to armature or magnet. Also, extremely important is that the cantilever must ensure that the stylus is placed correctly in the groove. And that is with angles. So we are talking about azimuth, we are talking about rake angles. So these angles must be correct. And that is also the job of the cantilever, making sure that this stylus is placed correctly in the groove. If not, you will not get the full musical experience out of listening to this cartridge. So you could say that the cantilever is the sort of the partner for the stylus. So if the cantilever is not doing what it's supposed to do, then the stylus cannot do its job. That's how it is. They go together. They are very important, both of them. If I now come back to this cantilever from the 2M red, as I told you, aluminum. So why do we use aluminum? We use aluminum because it's lightweight. That's a metal with low density, so it's a lightweight material. And in fact, this is a tube. That's an aluminum tube that we are using. And when you have a tube, you will also get some rigidity. So aluminum tube is a very straightforward way of having something lightweight and rigid at the same time. But on the other hand, you might know, or at least maybe heard about, that aluminum is not really a super hard material. Aluminum is pretty soft. So this means that we are using a not that hard material to make this tube. So it's not the best possible material to use, these aluminum cantilevers, but they are very convenient, and we use them for our moving magnet cartridges and also for some of our moving coil cartridges, because it makes sense to have the sound that we want from these cartridges. And also we are talking about quantity, and we're also talking about price point. Aluminum cantilever is definitely better to use if you talk about price point than what I will come back to later, for instance, a diamond cantilever. So, but they are very convenient to use and easy to use, and we use them for our moving magnet cartridges, as I already said. What else do we use as cantilever material, and why? So if we look at our moving coil series, we will use something like this that I'll take forward as two examples. So we have a ruby cantilever. You can see it's sort of reddish pink. We also use sapphire. I don't have it here, but sapphire is in fact just a colorless version of ruby. So the material itself is the same. So we use ruby and sapphire, which are mechanically, physically the same. And we use boron. The properties of both of these materials is that they are very stiff. They're very stiff material, so we have a nice rigid cantilever, and this is what we want to have. We really want to have this movement of the stylus in the groove to be transferred the best possible way to the armature. And now we're talking moving coil, so it's to the armature. So therefore ruby or sapphire or boron are perfect candidates for this. And these materials are also with a density within the range that will make sense for a cantilever. We do not want to use an extremely heavy material for cantilevers, because that will also make it more difficult for the stylus to move the cantilever around. So, but these materials ruby, sapphire, boron are pretty good at this. And what do you get out if you compare to aluminum? The loss in this kind of material is less than in aluminum. So the aluminum, even if it's stiff, it will sort of bend slightly, very slightly, but there will be some movements inside the aluminum cantilever when the stylus is in the groove and following the music. So you will have some loss in the aluminum cantilever, whereas when you go to ruby, sapphire, boron, that loss will be at a much, much, much lower level because we have this very rigid structure for these cantilevers. So you would experience better transients, you would experience more dynamic sound, you would experience more detail. So in fact, going from an aluminum cantilever to ruby, sapphire, boron is a big difference. There would be no doubt that you can hear it. So it's really improving the sound. This also means that these cantilevers, we use them together with more advanced styli, some with grindings that are more advanced than we use for the aluminum cantilever. I'll come back to these styli in a later video. I'm missing an important member down here, and because here I have the missing member to the cantilever family. That is a diamond cantilever. I'll not take it out to show you because I would destroy this cartridge, this MC diamond, and I really do not want to do that. So I have a diamond cantilever here. And what is this now with a diamond cantilever compared to the other ones that I have on the table? Diamond is, as you know, the hardest material in the world. So the hardest material, and also it has a crystalline structure. So these two things together, really hard material, crystalline structure, that ensures that the material used as a cantilever will improve the connection between the stylus and the armature when you compare to boron or sapphire or ruby. So it's really going one step further now to probably the best material available for cantilevers, diamond. We've been using that for some years now. I still remember first time when I experienced one of our cartridges with a diamond cantilever. We found out that it would make sense to try to experiment with new cantilever materials, and of course we had diamond in our mind. We found a supplier that were able to supply that, and that is not easy to make these very small thin rods of diamond cantilever. That is really a challenge to find suppliers that can do that. We got some cantilevers, we got them mounted with our sort of favorite diamond, which for me is the Replicant 100. And then we put them into already well-known systems, so systems where we would normally use a boron cantilever. So I had my cartridge, the Ortofon cartridge with boron cantilever that I knew extremely well. I've been listening a lot to that. And now I had the same cartridge with the diamond cantilever. And first time I was queuing down the record and gave it a listen, it was sort of a, wow, revelation. I was on my way back to my listening chair and I stopped in the motion because then the music already started. There was something that was really not just a small difference, it was significant. It was really like, what is going on? And back, queuing again quickly back to the listening chair and then listening. And no doubt, that was, you can call it a revelation for me. It was, wow, this means something. Going from boron, which at that time I thought would maybe be the best material, and now to diamond, really made a big, big jump in performance. So now, of course, diamond is my favorite material for cantilevers. And we use that only in our in our best cartridge. We use that in our MC Verismo, which I have here, and then in our MC Diamond. So this is the best possible performance that we can get out of these cartridges by using diamond cantilever, because it's hard and you have the crystalline structure. So to summarize about cantilevers, cantilevers is a very important component in the cartridge. So right from the beginning, when we are designing new cartridges, we are also considering what kind of cantilever should we use, taking all the different pros and cons into consideration and finding out what cantilever will suit the sound that we want for these different cartridges. So therefore, if we have a cartridge now with the ruby cantilever, that ruby cantilever has been chosen because that is the cantilever that will give us the sound that we want from that specific cartridge. So in that way, it's not just random, it's about to get the sound that we want from our cartridges. So that is important to notice that. Also, I want to comment a little bit more about this diamond cantilever thing, where sort of it was not an out of this world experience, but it was really sort of, this is what makes the life as a cartridge designer worthwhile. Not that it would not be worthwhile without it, but makes it even more worthwhile, because this experience you get when you hear something that may be unexpected is like, wow, is this what I've been missing all these years, all these extra things? Where did it come from? And you listen and you listen and you get really happy about this. So as a designer, for a cartridge designer, this is really exciting. Also for Ortofon and for me, this is also something that is exciting to present to the customers, to the listeners, because they will of course feel the same, they'll have the same experience, and this is what counts for Ortofon, really making cartridges that will provide this kind of experience, musical experience at home when listening to music.